Salam and welcome everybody. So today's lesson is about the reaction between carbonyl compounds, which are aldehydes and ketones, with HCN. The cyanide is the reagent that will react with aldehydes and ketones. So why do we have this reaction and what is the motivating force behind that? So let's start with a beautiful example, which is a propanone, C double bond O. Here we have CH3, and here we have CH3. According to what we learn, the hydrogen cyanide gives Cn negative, and it works as a nucleophile, as we can see. So this cyanide group, will work as a nucleophile, and it will come and attack the carbonyl group. And now the question is, why do we have reaction? According to what you see, oxygen is electronegative atom and it's partially negative, but if you go for carbon, in here it's partially positive. And as a result of difference in electronegativity, you'll have partially positive atom and partially negative atom. And this makes the carbon prone to attack by cyanidic group. And it will come and attack this carbon in here. But we have to put in our mind, we want to make, let's say, enhancement for this reaction. We have conditions. So these conditions are, you have to add, in addition to HCN, you have to add KCN, potassium cyanide. In this case, the potassium cyanide, put in your mind, this is very important, it works as a catalyst. Okay, it works as a catalyst. So it enhances the rate of reaction. And that's why you have to mix it with HCN so you can make the reaction faster. So the rule of KCN here is a catalyst. Okay, in addition to that, you have to apply heat. Okay, so once we apply heat and mix the HCN with a catalyst, which is KCN, we will have a beautiful reaction in here. So let's complete it down here. Here we have C double bond O, CH3, and here we have CH3. And as we told you before, we have Cn negative. It will attack from the carbon side. It will attack this carbon. Okay, but we just remember that the carbon never ever make 5 bonds. So these 2 electrons in the pi bond will move to the oxygen as a negative electrons that are accumulated in oxygen. And then you will find CO, the electrons in here become like this. And here we have negative charge on oxygen, as we can see. And here we have another bond that is formed, which is Cn. And you just remember that once the Cn bonded to an alkyl group, or let's say organic molecule, it's called nitrile. In this case, we can say that we have nitrile group. Okay, this is nitrile. All right. So we didn't finish. We told you before we added HCN, and you notice that oxygen is negatively charged in here. It will come and attack this hydrogen, and these electrons are accumulated in CN here. So you will notice that you will have a compound that looks like OH. Okay, so here we have OH because oxygen is negative, and we have hydrogen. It will come and attack the hydrogen. And we have CH3, and here we have the same thing, CH3, and here we have CN. If you just want to write this compound in form of displayed formula, we have a triple bond between the carbon and nitrogen. So yeah, if you want to write it in displayed formula, or if you were asked to draw it in displayed
Let's
take another example, which is ethanol, CH3, CHO. Okay, or it looks like this, CH3, C double bond H, or it looks like this. Yeah, this is ethanol. So let's start if I want to make a reaction between ethanol and HCN. So let's take here in this formula and just put it like this, C double bond O, and here we have hydrogen, here we have CH3. And as we can see, the cyanic group is negatively charged, and this is partially negative, this is partially positive. This cyanic group will come and attack this carbon. The carbon is no longer able to make 5 bonds. These electrons in the bond will transfer to oxygen. We're going to repeat the same issue, by the way. And then we have CH3 and CO negatively charged in here. and here we have H and CN. Okay, and then we have HCN. This will come and attack the hydrogen and remove it like this, and we will have these such a compound like COH, and you have hydrogen, CH3, and CN. By the way, if I ask you to name this compound in general, the first thing that you have to take the longest chain starting from nitrile group, okay? Because you have OH and you have nitrile. So we start from cyano group. So we can say like we have first carbon, and this is 2, and this is 3. So we have 3 carbons, which means propane, okay? Propane. And we have hydroxyl group, but we don't say, let's say, like alcohols, ethanol, propanol, whatsoever. In this case, once you have a different functional group, you have cyan group, or let's say nitrile group, and a hydroxy group, we stop calling it all. We stop calling like ethanol, propanol, okay? We start counting, or let's say naming, the OH group as hydroxy. So you have hydroxy, all right, and we have nitrile. Okay, so these are the things that you have to combine with each other. But we just noticed that we start counting from carbon with cyanic group, and we notice that the OH group is on the second carbon. So you can say you have 2 hydroxy, and you write the whole name, propane, and you put nitrile. We don't drop the E in propane, okay? But generally speaking, sometimes as a result of making reactions between the carbonyl compounds and cyanic groups, they stop saying 2-hydroxy, okay? So just like write it like this, hydroxy, propane, nitrile. Okay, and this is only special case when they make a reaction between cyanic groups and carbonyl compounds, because, or let's say the cyanic group is in the second carbon as usual. So this is by default, okay? But you have to put in your mind this certain type of naming. Okay, if you look at this carbon in here, you have OH, and here we have hydrogen, and here we have CH3, and here we have cyan, C. And by the way, guys, you have to put in your mind, the bonding is from the carbon side, it's not from nitrogen side, okay? So this is the first thing that you should put in your mind. And the second thing that you have to put in your mind, we notice that we have a carbon chiral center. And if I ask you to define the chiral center, first of all, you have to explain it in terms of stereoisomerisms. They have same molecular formula, they have same structural formula, but they have different arrangement in the space. And then you have to tell me that they have different groups around each carbon, or 4 different groups. So these are very important. My question is, how can I draw the optical isomers? Or let's say how to draw the enantiomers, or the mirror images. How can I draw that? So first of all, you will take this compound as it is and just draw it in 3-dimensional structure. And I just want to draw it. We have C, and C has OH, as we can see. I'm drawing this. And we have this one, okay, which is in the same plane. Okay, so the OH and CH3 are in the same plane. And then we have to do the dashed line in here, and it has hydrogen. And then we draw the wedge, which is, let's say, aligned to the dashed line like this, okay? All right, it's aligned to the dashed line, and it has CN, okay? And now it's time to draw the mirror image of this one here. You draw like this, and I'm going to show you how to draw the 3-dimensional structure of this compound. So we draw C, all right? We draw the stick. I just want to use the pen color in here. I'm going to draw this, okay? We have this stick, and we have OH, as we can see. All right, we have OH, okay? And then we have this dashed line, and we put it like this, C, and we have hydrogen. And as we told you, the wedge is aligned to the dashed line in here, and it looks like this. And here we have CN, and then we have CH3, as we can see. So just let's check it again and connect all of this stuff. We have OHs that are in the same level, okay? And we have carbon and you have hydrogen with the dashed line, the wedge are the wedge, and CH3s are the CH3s. So in this case, we just noticed that as a result of adding the cyanic group, you might have or you may have, we don't know, you may have a chiral center. So don't panic if you have such thing. Okay. So in general, guys, the compounds that contains OH and nitrile groups are called hydroxynitrile. Okay, and now I just want to recall something for you. We just remember that we produced something called hydroxynitriles, and it was as a result of reacting between the carbonyl compounds, which are either aldehydes or ketones, with KCN, HCN in the presence of heat. Okay, so we got hydroxynitrile, which means that you have a carbon that has alkyl groups and OH and cyano group. Okay, but it's not the only reactions that we can produce the cyano groups. Okay, it's not the only one. We have another one. And I just want to recall the reaction between halogen alkane, which was about, for example, like CH3, CH2Br. So in this case, if you want to make a substitution reaction, which was nucleophilic substitution, we can add KCN, okay, in the presence of ethanol as a solvent, which is a must in this case, and heat. So in this case, the CN nucleophile works as a nucleophile, kick the bromine out, and you will have CH3, CH2, CN. As we can see, we started with 2 carbons in here, but here we have 3 carbons. And by the way, if you want to name this compound, we take the longest chain that includes the carbon of cyanic group. And here we have 1, 2, 3. This is the propane nitrile.